Corporate Finance, Core Topic 6, Capital Budgeting, Learning Objective number 4. We're going to evaluate investments with cost only or cost savings only. So here's a first little investment we're looking at. We're deciding whether we're going to automate labor. A firm is considering replacing a manufacturing labor with robotics. The savings are expected to last 5 years until the product line is due for refurbishment. The robot will be depreciated over 7 years but sold at the end of the 5th year. So here are my assumptions. Robot will cost $500,000 today, be depreciated straight line over 7 years, be sold for $50,000 in 5 years, and we're going to save $150,000 a year starting at the end of this year, $150,000. The maintenance cost for the robot is $5,000 per year. That's OPEX. Tax rate 25%, discount rate 15%, and my net working capital from period 0 to 4 is $10,000, and then I'm going to set it equal to 0 at the end of the 5th year, because this is a finite life project. And I'm going to calculate the NPV, IRR, and payback of this project. Let's go to the spreadsheet and take a look. I've largely done this one for you. So here is my cash flow periods, 0 through 5. So today I'm going to buy the robot for $500,000, and my net working capital is going to be $10,000 today, but I'm going to hold that constant and take it to 0 in year 5. So I did a little shortcut here. I just put minus $10,000 here and plus $10,000 here. Normally I would have a little line item down here of net working capital, and I'd show it go from to 10,000, staying at 10,000, going to 0, and I would calculate the change. So it's a little shortcut. And now I'm going to calculate the annual free cash flows. So I'm going to do it a different way. I'm going to, instead of building an income statement and calculating EBIT after tax and adding back depreciation, let me just do everything in after-tax basis. So the trick in deciding whether you want to do some cost savings measure and whether it has a positive NPV is treat cost savings as revenues. So the absence of an expense is a revenue. So I'll take my savings, $150,000, anchor that, multiply times 1 minus the tax rate. Anchor that. So my after-tax savings is 112. Copy that across. My after-tax maintenance expense, 5,000 times 1 minus the tax rate, is 3,750. And the depreciation tax shield would be my 500,000 divided by 7. That's the annual depreciation times the tax rate. So instead of doing a full income statement to get to EBIT and add back depreciation, I could just take my after-tax savings minus my after-tax OPEX plus my depreciation tax shield. Then I can add back depreciation, subtract CapEx, minus changes in net working capital, and get free cash flows. By the way, here's my residual here. Since this asset is paid back, or I'm sorry, is sold in year 5, I did keep track of the net book value down here, and I have my after-tax residual. All right, so that should actually say minus CapEx plus salvage. And so here are my free cash flows. I calculate the NPV. It's actually negative, so we keep the labor. It's not cost effective to replace the labor with robotics. The discount rate again is 15%. The IRR is 11.53, which is telling you also not to do the project since the IRR does not exceed that discount rate. And the payback is in cumulative cash flows. Payback is in 5 years. But again, this is not discounted payback. The discounted payback would never happen. It's just, but the payback is in 5 years if you ignore the time value of money. So let me think about this little shortcut method. I just took my after-tax savings, or revenue, if you had revenue in this project, minus the after-tax OPEX plus depreciation tax shield. Now I could have done it a long way. So this column here could have been replaced with all of this. My revenue or my tax savings minus OPEX minus depreciation, that's EBIT. Take out taxes, add back depreciation, I get 126.6. So I could have done it that way. So it's just kind of a shortcut method to think about the after-tax value of each line item separately versus handling taxes at the bottom and then adding back the non-cash expense of depreciation. So we're not going to do it. We're not going to replace the labor with the machine. All right, let's do another one. Do I buy machine A or machine B? So a firm will require a machine to perform some necessary task, whatever it is. There are two possible machines of unequal lives. And so when you have that, you're not going to be able to compare them using NPV. We're going to have to calculate the effective annual cash flow or effective annual cost to determine which is cheaper. We're going to turn it into an annual payment. So here's the data. I have machine A or machine B. Machine A lasts for 3 years and it's cheaper. Machine B lasts for 5 years, it's more expensive. I got my salvage values, my OPEX per year to keep the machine going, my tax rate and discount rate's the same, and there's no working capital for these. So let's look at machine A. It'll have zero revenue impact, but OPEX of 75,000 or 75 per year, depreciation of 100 divided by 3. Got my EBIT after tax, add back depreciation, and there are the free cash flows for the first machine. Machine B is down here, just a little bit different numbers. I'm going to have a higher depreciation because it's larger capex, but I'm going to divide it by 5 years and have different OPEX. So let's take a look at the spreadsheet. Cost only. So I've calculated my free cash flows for machine A, which is a 3-year machine, and the 5-year machine, machine B. Calculate the NPV. So the NPV of the short-lived machine A is lower than the machine B. I need this machine no matter what, so I would choose machine A if I only used NPV, but this isn't a good comparison because this machine lasts 3 years, this one lasts 5 years. So in theory, if you need 5 years of services from this machine, you'd have to buy another one of these machines out here. But the easier way to do that is just convert these unequal lives. And again, I'm going to do machine A or machine B. These are mutually exclusive projects and they have unequal lives. So I'm going to do EAC by converting these to payments. So I'm going to put in a equals payment, put in a discount rate. I'll anchor it since it's the same for both. Where it says number of periods, I'll put 3 for machine A, comma, net present value of machine A. So that is equivalent to $82 a year. I'll copy that formula here, except for this one lasts 5 years. So machine B clearly is cheaper per year. It's $68 per year versus 82. So I am going to go with machine B. So in this topic, we evaluated investments that have cost and savings only.